Close your eyes for a moment. Imagine standing under a clear night sky. The stars look timeless, scattered like glitter across an endless canvas. But then something shifts. At first you think it's your imagination. A star twitches, another bends. Then suddenly an entire patch of sky warps into a swirling ring, as if some invisible hand is pulling light itself into a whirlpool. And that's when scientists announce the unthinkable. A black hole, one of the universe's deadliest monsters, has wandered into our solar system. Its destination? Earth. This isn't science fiction. Black holes are real. They're out there, roaming space, swallowing everything unlucky enough to cross their path. And if Earth were caught, what would happen? Would we burn? Freeze? Stretch like strands of spaghetti? Or would we simply vanish, erased from existence? Tonight we're going to unravel the terrifying and fascinating story of what would happen if Earth fell into a black hole. From the moment of detection to the final second before we're gone, you'll see, in vivid detail, what would happen to our planet, our people, and maybe even reality itself. Because when it comes to black holes, the truth is stranger and scarier than anything Hollywood could dream up. Before Earth meets its fate, we need to understand what we're dealing with. So, what exactly is a black hole? First, let's clear a misconception. A black hole is not some giant cosmic vacuum cleaner sucking things up from across the galaxy. It's actually far stranger. A black hole is a region of space where gravity has become so intense, so overwhelming, that nothing can escape it. Not even light, the fastest thing in the universe. That's why it's black. But how does such a thing form? The story begins with stars. Stars aren't just twinkling lights. They're titanic nuclear furnaces, each one a balance between two competing forces. On one side, gravity pulling everything inward. On the other, fusion, the nuclear reaction in the core that smashes hydrogen atoms into helium, releasing massive amounts of energy. That outward pressure keeps the star from collapsing under its own weight. But fuel doesn't last forever. When a star about 10 times more massive than our sun runs out of hydrogen, fusion stops. Gravity wins. The core collapses inward with unimaginable force. Temperatures soar to hundreds of millions of degrees. The star detonates in a supernova explosion so bright it can outshine an entire galaxy. What's left depends on the star's size. A medium-mass star may shrink into a neutron star, an object so dense that a teaspoon of its material would weigh 1 billion tons. But if the star was massive enough, gravity crushes it further, to the point where matter itself can no longer resist. The collapse continues until all the mass is squeezed into a point smaller than an atom, a singularity. Surrounding this point is an invisible boundary, the event horizon. Think of it as the ultimate point of no return. Anything crossing it, a planet, a spaceship, even light, can never escape. And the strangest part? Black holes bend the very fabric of reality. Near one, space stretches, time slows. To a distant observer, someone falling in would look like they're frozen at the edge forever. Inside, the laws of physics as we know them collapse. Einstein's relativity breaks. Quantum mechanics doesn't work. It's a riddle at the center of the universe. That's why black holes are terrifying and irresistible. They aren't just cosmic monsters. They're mysteries carved into the universe itself. Now let's bring the nightmare closer to home. Imagine astronomers detect a black hole drifting toward us, not colliding yet, just entering our solar system. At first, there would be no panic. Black holes don't glow. They don't give themselves away. The only clue is how they bend the light of stars behind them, creating eerie halos called Einstein rings. But slowly the consequences would unfold. The sun holds our solar system together with gravity. The planets dance in stable orbits around it. But a black hole's immense gravity would distort that balance. Jupiter's orbit might shift slightly. Saturn could drift. Earth's path would stretch into an elongated oval. That tiny change would wreak havoc on our seasons. Imagine winters lasting twice as long, summers scorching hot, crops failing worldwide, economies collapsing, billions struggling to survive. Even before touching us, the black hole's gravity would make life on Earth nearly impossible. Satellites would drift off course, GPS would stop working, communications would break down. Tides would surge unpredictably as the black hole's pull competed with the moon's. Coastal cities could flood, and the night sky, it would look broken. You'd see stars warped into distorted halos, some stretched into strange arcs, others flickering as their light bent around the black hole. It would be beautiful and horrifying. Now imagine the worst-case outcome. The black hole doesn't just pass by, it begins to capture Earth in its pull. We'd become a rogue planet. Ripped from the sun's orbit, Earth would drift into the darkness of interstellar space, frozen solid within months. The oceans would become glaciers. The atmosphere would collapse. Humanity's last survivors would cling to underground bunkers powered by nuclear fuel. All of this without even touching the event horizon. But what if the black hole's pull grew stronger and Earth fell directly toward it? The first sign wouldn't be instant destruction, it would be stretching. Scientists call it spaghettification. Gravity doesn't pull equally. It's stronger on the side closer to the black hole than the side farther away. Normally, this difference is too tiny to notice, but near a black hole, the difference is extreme. If you fell in feet first, your legs would be pulled harder than your chest harder than your head. Your body would elongate into a thin strand. Now scale that up. Earth itself would stretch. The side facing the black hole would be ripped first. Continents cracking. Oceans rising into space as streams of water. Mountains torn apart, their rocks spiraling upward. But here's the strange part. To us falling in, time would feel normal, seconds ticking by as usual. But to anyone watching from far away, Earth would appear to slow and slow and slow. At the edge of the event horizon, Earth would look frozen, glowing faintly red as its light stretched into longer and longer wavelengths. Eventually, it would fade entirely. To the outside universe, Earth would simply vanish. But inside, the ride would be violent. Skies torn into twisted crescents of light, cities collapsing as tectonic plates ripped under tidal forces, the oceans boiling into vapor streams, people thrown against the ground as gravity tore at their bones. And then, the plunge, crossing the horizon. No escape, no return. But what would we see? Would we survive even a second? Or would there be something stranger waiting? Now the moment arrives. Earth is no longer just approaching. We are falling. Ahead of us lies the event horizon, the invisible boundary that separates the universe we know from the unknown. From far away, it looks like a sphere of darkness, perfectly black, wrapped in a halo of distorted starlight. It doesn't shimmer, it doesn't glow. It's simply absence. As Earth plunges closer, everything speeds up. Mountains rise into the air as tectonic plates snap. The atmosphere shreds into glowing streams of gas, spiraling toward the horizon. Satellites burn and vanish. From the surface, the sky is a nightmare. Stars no longer look fixed. They streak, bend, and duplicate as light is warped. Some vanish entirely as their paths are bent away from Earth. And then, we cross the event horizon. What happens next depends on perspective. For a distant observer, say aliens watching through telescopes light years away, Earth never truly enters. Instead, it freezes at the edge, stretched and distorted, glowing faintly red as its light is stretched into invisible wavelengths. To them, Earth hangs there forever. But for us falling in, we pass right through. No wall, no flash, just a boundary we can't detect. Except for one fact. From this moment on, escape is impossible, and gravity begins to dominate every second of our existence. So what's it like inside a black hole? The honest truth is, we don't know. Physics itself breaks down. But let's walk through what theory suggests. Once inside, space and time switch roles. Normally, you can move through space freely, but you're carried through time in one direction. Inside the horizon, it's reversed. Moving toward the singularity is as inevitable as moving into the future. You can't stop. You can't turn around. It's not just gravity pulling you in, it's reality itself. Earth, still intact for the moment, is being torn apart. The tidal forces are so extreme that the crust, mantle, and core separate into streams of molten rock. The oceans rise into vapor plumes, glowing as they rub against each other in the accretion stream. And time? This is where things get strange. For those falling in, seconds pass normally, but the view outside is bizarre. Stars on the edge of the horizon appear frozen, smeared into arcs of light. The entire universe looks like it's rushing into the black hole with you. But the singularity, the infinitely dense point at the center, is waiting, and no force in the universe can stop the plunge. At the center of every black hole lies the most terrifying object in physics, the singularity. It's not just a dense object. It's a place where the laws of the universe break. Imagine all of Earth, the continents, the oceans, the people, the atmosphere, the entire history of the planet, crushed into a volume smaller than a grain of sand. That's what happens here. But here's the twist. Physics can't actually describe this point. Einstein's general relativity predicts it, but relativity can't handle infinities. Quantum mechanics, the physics of the very small, also fails. At the singularity, space, time, matter, and energy are all tangled in a way we cannot comprehend. What happens to information? To the record of everything Earth ever was? That's the information paradox. If black holes truly erase information, it breaks quantum physics. If they don't, then somehow, in some form, Earth's story is still encoded. Maybe in the faint ripples of Hawking radiation, or smeared across the event horizon itself. For us, though, the ride ends here. Earth as a planet no longer exists. Its matter joins the singularity. Its story is over. But could that story continue somewhere else? Some scientists believe the singularity isn't just an end, it could also be a beginning. One theory, black holes might act as wormholes, tunnels through space and time. If that's true, then falling into one could mean emerging elsewhere in the universe, or even in another universe entirely. Another theory is even bolder. Inside every black hole, a new universe is born. In this idea, the Big Bang itself was the result of matter collapsing into a singularity in another universe. Our universe, in other words, could be the inside of a black hole from somewhere else. If that's true, then Earth's destruction might seed another cosmos, a rebirth on an unimaginable scale. Of course, these are just theories. No one knows for sure. But the possibility that death inside a black hole could also mean creation is both haunting and beautiful. Black holes don't live forever. According to Stephen Hawking, they emit tiny amounts of radiation. Over unimaginable timescales, trillions upon trillions of years, they evaporate. So even if Earth's story ends inside, the black hole itself won't last forever. Eventually it too will vanish, leaving behind only faint whispers of what it consumed, which means in the deepest sense, nothing in the universe is truly eternal. Not stars, not galaxies, not even black holes. Everything ends. And yet, in those endings lie the seeds of something new. So what does this all mean for us here and now? If Earth ever did fall into a black hole, our story as humans would end. But in a way, our story has always been temporary. What black holes really teach us is humility, that we are small, fragile beings in a vast, incomprehensible cosmos. But they also teach us wonder, because as terrifying as black holes are, they are also evidence of the universe's creativity. They show us that reality is bigger, stranger, and more mysterious than we can possibly imagine. And maybe that's the point. We may never solve the riddle of what truly lies inside, but maybe we don't need to. Maybe it's enough to know that we're part of a universe where such mysteries exist. Because if black holes teach us anything, it's this: the impossible is possible. So, what if Earth fell into a black hole? The truth is, we'd be gone. But maybe, just maybe, we become part of something greater. The end of our world could be the beginning of another. Thanks for joining this journey. Subscribe, because next time, we'll explore the strangest planets in the universe and ask, could any of them be home?